Natural modular building techniques always begins with an all-purpose center of everything. Any structure we explore will share this central location. The sphere and its vast structural memory embedded in its structure is a logical system to surround our center. I call it the you-me ball because it allows you and me to be one local observer. Choosing a real-life sphere, a regulation ping-pong ball, defines our all-purpose scale number that all measurements will be relative to. Radius equals 2 centimeters, the BB belly button number. Measuring with spheres is always center to center. From the beginning of my explorations of natural design, I knew I needed to develop a framework where any fundamental structure would have the same relative size, location, and alignment for comparison and contrast. In collaboration with the Brazilian architect Fabiano Schwabe, we developed the 4 landmarks all geometrical systems are relative to: the all-purpose center, the maximum sphere of influence of the center that defines a relative size field in the first limits of initial growth, slicing that sphere in half that defines an equator, and 90 degrees to the equator is the axis of spin that passes through the center. Within these landmarks are the communication networks that interconnect the center with the 3 fundamental locations in common on the outside limit of any structure: the outside corners, the symmetric division of the outside edges, and the centers of the outside shapes. I began my analysis of natural structural integrity with the closest packing of same-size spheres, one of the most fundamental structural numerical constants found in nature. It is the ability of spheres of the same size to pack together in a most effective minimum arrangement. It takes 12 spheres to build a first layer of closest packed spheres around our you-me ball. That arrangement defines a 14-sided vector equilibrium, or as the ancient Greeks called it, the cube octahedron. This geometrical system becomes the primordial balanced state where all the forces pushing out are equal to all the forces pulling in. Another unique innovation of natural modular is defining interconnectedness or synergy by containment fields. Basic geometry can be organized like nesting dolls, where one system fits exactly inside another, and then that fits inside another, and so on. The sphere has 2 beginning containment fields, an interior and exterior limit. The VE, the vector equilibrium, is on the inside, and the rhombic dodecahedron, or R dodeca, contains the outside limit. The R dodeca has all of the self-organizing properties of a sphere with the practicality of flat surfaces to build with. How everything fits together so seamlessly grows out of the communication networks among essential parts. Each essential part knows its exact relationship with every other part. Change one and they all change in unison to maintain a constant relationship. Buckminster Fuller explored these ideas in detail and developed the A, B, and T modules that are the most effective minimum symmetric division of the volumes of basic geometry. The AB mods build the sphere family, the all-space filling, and the T mods build the bubble family, the 5-fold symmetries. These most effective minimum modular units are defined structurally by a natural design pattern, multiplication by division. A single cell uses this to grow, and so does fundamental structure. The more you divide, the more information you have. Here you can see the VE inside a sphere divided by interconnecting all of the basic locations in common on the outside of any structure. This produces the fundamental triangles that defines the sides of the modular units. The order that radiates out from the center is divided using 1/2, 1/3 division in the sphere family and multiples of the golden ratio in the bubble family. Let's take a closer look at the bubble family divisions. Here the sphere is defined by 4 6BB circles interconnected in 60-degree relationships. The VE's edges are first divided in half to position the sphere family. The bubble family always has a spin, clockwise, counterclockwise. Take an edge and divide it in the basic GR squared division, and you define one type of spin. You use the same division but start at the other corner, and you have a second type of spin. If you want to construct the internal order of the bubble family, a practical place to begin are these division patterns. The cone-like structures that define the icosidodeca use these divisions to order their placement. All division in the bubble family use them. There are only two formulas used in all of natural modular building techniques. One to calculate the golden ratio, and the other is the Pythagorean theorem defining the constants of a 90-degree triangle. I define the golden ratio, GR, as a ratio between 0 and 1. Traditionally, it's been expressed as between 1 and 2. Because it's a ratio, its calculating power doesn't depend on whether it's between 0 and 1 or 1 and 2. It depends on what you're looking for. I found the less than 1 ratio reveals many more interconnected building patterns than the more than 1 ratio. The GR formula begins with the square root of 5 equals 2.2 ... To calculate this GR, subtract 1 from the square root of 5 and then divide by 2. Simple arithmetic is all you need. The 90-degree triangle formula, the Pythagorean theorem, shows the always true relationships between the three sides of this triangle. If you know two sides, then you can know the third. I use this formula to mathematically prove my BB numbers. On a relative size field, where we know all the distances, we construct a 90-degree triangle with a base of 6 BB equals 12 centimeters. This becomes the B side. Its longest side is double that, 12 BB equals 24 centimeters. This becomes the C side. Pictured here is all the different orders of the arrangement to find the side that is unknown. We want to find the A side, so we will use A squared equals C squared minus B squared. Multiply C and B times themselves, and then subtract B squared from C squared. Take the square root of that number, and you now know the A side. That number just happens to be the square root of 6 BB. Proof of my BB measuring system's use of the four basic primordial numbers, multiples of the square root of 2, the square root of 3, the golden ratio, and the square root of 3.618. No other formulas or higher mathematics are used. I'm so old school, I'm ancient school. This is why I reduced the 5 color-coded basic shapes to a 90-degree triangle. All of the color-coded constants, we have constructed a system of self-organizing triangles. Know one side, you know them all. The 90-degree triangle formula proves this.